Okay, so this evening we are doing Friday the 10th of November. So here we have our grade boundaries and our cumulative total. Now what's also really useful, and you've probably seen a lot of by now, are copying all them down. So they are our formulas that would be very useful to you. Now this is a non-calculator paper, so we're not going to be using the SOHCAHTOA trig triangles, but we could possibly be using the other ones. Okay, just copy them down. Okay, hopefully you should know those by now. Okay, right. Let's move on. Question number 1. Okay, so 3 to the power of 4 multiplied by 10 to the power of 3. Now, the easiest way to do this is to actually write down what each of them are. So 3 to the power of 4 means 3 times 3 times 3 times 3. So 3 times 3 is 9, times by 3 is 27, times by 3 is 81. 10 to the power of 3 is 10 times 10 times 10, which is 1,000. Now we've worked both of those out, and what we have to do is multiply them together. So 81 multiplied by 1,000 is 81,000. Okay. Part B. 1 divided by 0.5. Well, when we divide something by 0.5, we double the value. So 1 doubled is 2. Okay, C. 5.6 take away 3.82. So the best way to do this one is to probably set it up in the columns method, remembering to align your decimal point. That there is really important. Now we have a gap here where we would put a 0. Okay, and now we're going to take away, starting from the right hand side. 0 take away 2. Well, we can't do that, so we borrow from the next column. That drops down to a 5. That creates 10. 10 take away 2 is 8. 5 take away 8, we can't do that, so we're going to borrow from the 5. 15 take away 8 is 7. 4 take away 3 is 1. And not forgetting the decimal point that lines that up there. So 5.6 take away 3.82 is 1.78. Okay, D. 5/6 take away 2/3. Now, our denominators are different here and they need to be the same so we can perform this calculation. So I can change this fraction on the right hand side to an equivalent fraction that has a denominator of 6 by multiplying the bottom and the top, so the numerator and the denominator, by 2. Our first fraction stays exactly the same, and our second fraction, our equivalent fraction, becomes 4/6. And now I can perform that calculation because our denominators are the same. 5 take away 4 is 1. So our answer to the question is 1/6, and that's already simplified. I can't do anything to that. And E. 0.2 times 0.3. Well, if we just ignore the decimal points for now and do 2 times 3, our answer is 6. But in our question, we have 1 decimal place here and 1 decimal place here, which means my answer must have 2 decimal places, which creates 0.06. Okay, so some of those are just 1 mark questions, so you just get the answer for that. For this first one up here, you get the 2 marks. 1 mark is for showing either the 81 or the 1,000, so one of those, and then the other mark is for having 81,000. You get both marks if you have 81,000. Okay, so 1 mark for that, 1 mark for that. There's 2 marks for part D, and your first method mark is for correctly using a common denominator. So if you've used a common denominator, if you did a different method and still did that correctly, you would get the method mark for it. So I'm just going to put the M1 there, and then you get the answer mark there for 1/6, and then that last one there is just a mark. Okay, on to question number 2. Okay, true-false questions. Now, there is always space for working with these, and I suggest you use it if needs be. So let's read this question. Circle either true or false for each of the following statements. The expression G multiplied by G multiplied by G can be written as 3G. Now, when we multiply a letter, that gives us an indice. So that would actually become G cubed. G cubed is not the same as 3G, so that is false. Okay. The expression 7y take away y can be written as 7. Well, if I did 7y take away a y, my answer would be 6y. So the answer to that is false. Okay, next one. A over 4 divided by A equals a quarter. Okay, let's work that out. If I've got A divided by 4, and I'm dividing that by A, what would you do? Yeah. Okay, so the easiest way to do that one would be to change this side into a fraction and multiply by the reciprocal. So we're going to have A over 4 multiplied by 1 over A. And if you see, our A's then would cancel out, and I'd be left with 1 over 4. So that in fact is true. Okay, next one. A over 2 added to A over 2 gives us A. Well, that's half an A. So is that. 2 halves do make a whole. So that is true. And the last one, when A is 1, B equals 2 and C equals 3, A plus B plus C equals ABC. Well, with this one, we just have to work it out. So if we added them all together, so if we added 1 to 2 to 3, well, 1 add 2 is 3, add on another 3 gives me 6. Now let's see what we get when we multiply them. 1 times 2 is 2, times that by 3 gives us 6. So yes, it does come out with the same answer in this instance. So that there is true. Okay, on to question 3. In this part of the question, you will be assessed on your quality of your organisation, communication and accuracy in writing. We've got 4 marks for the maths of this and 2 marks for how we are setting this out, making sure they're including all our units and making sure that our spelling and everything is quite logical. So, calculate the height h of cuboid B. You must show all of your workings. Sorry, I missed this bit. The two cuboids shown have equal volumes. Now, that tells me that the volume of this cuboid is equal to this cuboid here. So to work out this height, before I can do anything with this cuboid, I need to work out the volume of the first cuboid. So I'm just going to write that that's what I'm doing. Volume of cuboid A. Now to work out the volume, we take the 3 dimensions and we multiply each of them. 6 times 2 times 3. So the cuboid is the lovely one to work out the volume for. So 6 times 2 is 12, multiply that by 3, that gives me 36 centimetres cubed. And make sure you're putting your units on these ones. The OCW question, make sure the units are on there. So, volume of cuboid B. Okay, I'm going to set up a bit of an expression for this one because I'm not given all of my dimensions. I've got 2 by 2 by h. So 2 times times h. Well, 2 times 2 is 4, multiplied by h gives me 4h centimetres cubed. So I've got a bit of an expression for that, but I'm trying to calculate h. They're both equal volumes, so I know that these two are equal to each other. So I can say that 4h equals 36. So 4 somethings are 36. That something is 9. So the answer to this question is 9 centimetres. Okay. Part B. How many cubic centimetres, so centimetres cubed, are there in 2.5 litres? Now, 1 litre is 1,000 centimetres cubed. So 2.5 litres is going to be 2,500 centimetres cubed. Okay. The marks for this question. So you are given 4 marks for the maths of this question. The first one is a method mark for having 6 multiplied by 2 multiplied by 3 gives us 36. The second method mark is for having some sort of expression for the second cuboid. The next one is a method mark for equating them, and then your answer mark for the last bit there. And provided you have a logical order of your work, you should get those 2 marks for the accuracy of writing and then the other one for the organisation and communication. Okay, and then the last one is just a 1 mark question. Okay. Question number 4. A fraction is written as a over b. The fraction is a multiple of 0.2. The fraction is greater than a half. The fraction is less than 75%. Write down the fraction as a over b, where a and b are whole numbers. So, that's the question. I'm going to reread back through that. So, we are looking for a fraction. It must be a multiple of 0.2. So I'm going to write those down. 0.2 as a fraction is a fifth. So I'm looking for a multiple of that. So either it's going to be a fifth, 2 fifths, 3 fifths, 4 fifths. Can't imagine it being 5 fifths, but that takes us up to the whole there. Okay, so that's that first one done. The second part, the fraction is greater than a half. Now, a half, all of those are greater than a half. So it's going to be one of these. The fraction is less than 75%. Well, 75% would be between these two. So I'm looking for one less than, which is going to be that way, which leaves us with that one option of 3 fifths. Okay, and that's worth 3 marks. It's a lovely 3 marks to have there. To break it down for you, you'd get 2 marks for meeting 2 of these conditions, and then the third mark then is for making sure you have that 3 fifths there. Okay, you'd also get 1 mark if you only met 1 of them. Okay, okay, on to question number 5. Write down the next 2 numbers in the following sequence. So it gives us a sequence of 22, 21, 18 and 13. Now this is a sequence and I need to know what my gaps are. So between 20 and 21 I have subtracted 1. Between 21 and 18 I've subtracted 3. Between 18 and 13 I've subtracted 5. Now with my subtractions I can see a bit of a pattern forming here. It's 1, it's taken away 1, then 3, then 5. So our subtraction, our difference is increasing by 2 every time. So my next jump is going to be subtracting 7. So that gives me 6. And the next jump then is going to subtract 9, and that gives me minus 3. Okay, 2 marks, 1 there for each. Next question is a 1 mark question on expanding brackets. Now, we've got 5 bracket 3x minus 2 close bracket. When we are expanding brackets, all we do is multiply our outside by our inside. So 5 multiplied by 3x gives me 15x, and 5 multiplied by minus 2 gives me minus 10. And that is my answer. I can't simplify that. There's no x on the end of that to combine them. I can't go any further there. Okay, now we have a solving equation as part C. So this is worth 3 marks. We have to solve 9x plus 3, which is equal to 4x plus 5. Now there's several different ways and several different methods of doing that. Now you look to see which side x has the greatest value. So the 9x is greater than the 4x. So I need to remove this 4x. So I'm going to take 4x from both sides. So both sides of the equal sign. So I have my equal sign there. 9x take away 4x gives me 5x. Add 3 equals, well, 4x take away 4x, that's now disappeared. And I'm left with a positive 5 on that side, so I can write 5. Now I've got 5x plus 3 equals 5. So something added to 3 equals 5. Well, that something is going to be 2. So I've got 5x equals 2. And x is therefore equal to 2/5. Okay. And as I said, that's worth 3 marks. So your first mark is for getting down to here and getting x only on the one side. The second mark is another method mark for getting down to there, and then you've got your answer mark. It's actually a B mark, sorry, to there. Okay? Yeah? Okay. Number 6. Okay. Sarah is in charge of a game at her school's Christmas party. 2 fair spinners are spun as shown in the example below. People can make a 2-digit number using the numbers shown on the spinners using the following rule. They multiply the number on the first spinner by 10, and then they add the number on the second spinner. So one example as shown above makes the number 21 because the first spinner has landed on 2, so we do 2 times 10, and then we add the 1 on the second spinner, so that gives us 21. First question is, how many different numbers can be made playing this game? So I could have a tens of a 1, I could have a 11, a 12 and a 13. I could have a 21, a 22 and a 23. Or I could have a 31, a 32 and a 33. So all in total there are 9 different combinations. Okay. Write down all the prime numbers that can be made play in this game. So again, I'm going to go through all those numbers and writing down which ones are prime. So starting with our tens of 1. So we've got 11, that is prime. 12, well, 12's an even number, that's not 2, so that's not prime. 13, that is also prime. Okay, next, 21. Well, 21 is divisible by 3, so that's not prime. 22, again, can be divisible by 11. 23 is our next prime number. And on to the 30, we've got 31, which is a prime number. 32, again, is a even number. And 33, which 11 goes into. So we have those 4 prime numbers. Part C. What is the probability that a person makes a prime number when playing the game once. So there are 4 possible prime numbers out of 9 possible outcomes. So the answer is just 4/9. Okay, next part of the question. I'm going to put them side by side. Sarah charges each person £1 to play the game once. Each player who makes a prime number from their spin wins £2. How much profit would the school expect to make when 180 people play the game? So let's have a look at this. So first off, I'm going to work out how much money is going to come in. So money in from the game. We have 180 people playing it, and they're each going to pay £1 for it. So that's nice and easy, £180. Okay, our money out. Each person that wins this game, we are going to pay £2. But first off, I need to figure out how many people win. So there is a chance from here of winning of 4/9. And there are 180 people. Now this is a non-calculator paper, so I'm going to look to see what I can do to that to make that a little bit easier. So looking at that there, 9 goes into 180, so I can cancel that, and it goes in 20 times. 4 times 20 gives me 80. So 80 people win the game. Each of those 80 people get £2. So my money out is going to be £160. So I'm just going to check my question. How much profit would the school expect to make when 180 people play the game? So I'm looking for profit. Now profit is my difference between my money in and my money out. So we've got 180, take away 160. So the profit expected would be £20. Okay, let's have a look at the marks for that one. So part A is just 1 mark, so that's 9 there. Part B, you get all 2 marks for having all of those 4 there. You would lose a mark if you had 2 incorrect. So you get a mark for having 2 correct. Okay. Part C is worth 2 marks, and you would lose a mark if you have carried on your answer from here. So that's a pretty nice 2-mark question actually. And part D, if you separate that down, you'd get a method mark for doing this part. Sorry, green pen. You would get an actual mark for working out the 80. So that method mark, sorry, is for this workings out here. Another method mark for doing this bit, and then you've got your answer mark for that. But I quite like that question, that's a lovely question. Okay, question number 7. Okay, ABCD is a quadrilateral. Angle ABC is 93 degrees, so that's ABC, and it's already on our diagram. BCD is 122, and ADC is 85. Points P and Q lie on the quadrilateral as shown, such that AP is equal to AQ. Prove that the triangle APQ is an equilateral triangle. You must show all your workings. Now, when you have a question like this, the first thing you should do is to make sure that anything that's up here is on your diagram. So the 3 angles are already on there, but it says at this line here that AP equals AQ. So that means that this part here, AP, that line there is equal to AQ there. So we usually use these lines to show that they are equal. So straight away, if those 2 are equal, that this triangle down here is at least an isosceles triangle. Okay? We have to prove that is an equilateral triangle. So we want that these three are the same. So in an equilateral triangle, what we need to have is that each of these are 60 degrees, because that's the only option for an equilateral triangle. I have a quadrilateral to start with. Now my quadrilateral angles should total 360. So I'm going to see what this one is down here first. So if I add those three together first, so if I do 85, add 122, add 93, that totals 300. So if I do 360, take away those three angles, that does in fact give me 60 degrees there. Now that's not enough to prove that just yet. In our triangle, I definitely know that this is an isosceles at least, because it tells us that and that. With an isosceles triangle, those two angles that are on our same length lines are going to be equal as well. Now I've already worked out that this is 60 degrees. So if I do 180, which is what these three should add up to, take away 60, that gives me 120. That 120 has to split equally between those two. Divide that by 2, that does give me 60 degrees. So there we go. That is showing that all of these are 60 degrees, and therefore this triangle is an equilateral triangle. So I'd probably pop a little sentence on there. All angles are 60 degrees. Okay, so therefore it is an equilateral triangle. So your method marks on this one. You first get a method mark for doing this up here, totaling them and totaling them up to 360, and then you get a method mark for showing that 60 degrees, sorry, an answer mark, that should be an A. Then, for this method down here, you get a method mark and an answer mark, and that last mark there is for making that statement that they are all 60 degrees and therefore must be an equilateral triangle. Okay, question 8. Now, look at the following descriptions of special quadrilateral shapes. Circle the correct name for each one. Okay, its diagonals intersect at 90 degrees, and only one diagonal is a line of symmetry. That has to be a kite, because if we think of the shape of our kite, our diagonals would run here, and they do in fact cross at 90 degrees. This diagonal here, this one, would act as our line of symmetry. So there's our kite. Okay, only one pair of sides that are parallel. So that is going to be our trapezium. Okay. Next one. All four sides are equal and its diagonals are not equal in length. Where our two quadrilaterals that are equal are both the square and the rhombus. But this bit here is key. Its diagonals are not equal in length. So a square, those diagonals there are going to be the same length as each other. So therefore it's going to be the rhombus.